Hey guys, it is the Diesel Queen. I am back with another episode of my podcast. Today I have a special guest from Industrial Injection. He is actually one of the CEO's sons, so he knows a lot of the ins and outs of industrial injection specifically, but today we're going to be more diving into the actual technical side of the fuel systems and turbos and stuff like that. So I'm super excited. So go ahead and do your introduction and tell us a little bit about you.
Yeah, thanks for having me on. I think it's inspiring what you're doing for the diesel community, and we love seeing everything that you do for it. And my name is Brighton Williams. My dad is actually Shane Williams. He's one of the owners of Industrial Injection, and I've kind of grown up with it my whole life. I currently work down at the machine shop down here in Richfield, Utah. I do a lot of the machine work. That's what I specialize in, but I've been rebuilding turbos ever since I was a little kid. So it's just been great to be able to grow up in this industry. And yeah.
Perfect. So to kind of like, I would love to touch on the machine shop side of it too, because I have lots of questions with that, or like questions that like I've gotten asked before that like I know the generic answer to just from experience, but I don't know the in-depth like it answers to. But to start out with, for those of you that don't know, and I promise this is not an ad, like giant ad podcast, I fucking promise, guys. But to start off with, industrial injection does a lot of the aftermarket diesel parts, but their main thing that they do, or at least you can correct me if I'm wrong here, but the main thing that they really dip into is fuel system components from like fuel pumps and injectors. They also do turbos. And this is not just for the automotive side. You guys actually started in the heavy duty side of things, correct? Or am I wrong?
Right. Yeah,
Yeah.
when my grandpa first started this business, he actually was rebuilding all your old agricultural equipment for farms and semi trucks, and that's kind of where it all started. And then it kind of turned into the once the common rail became a thing, they started getting into that, and that started taking over really big, especially when industrial injection started getting into the racing scene and started competing with the common rail stuff because that new technology kind of took over the game and just we ran with it ever since then.
So for the audience that does not know what common rail is, the difference between the original, like the VP44 style, like rotary pump setup that the second gens have, and a common rail, which common rail, the heavy duty industry has been using common rail for a long time. And the reason for that is it's a little bit more efficient and you can build better pressure. So for the audience that doesn't understand what common rail is, instead of having 6 lines that go from the pump to the injectors and the timing of those injection sequences is from the pump. So there's no pressure in those fuel lines until it's that injection sequence from the pump. The common rail has 1 line from the high pressure pump to what's called a common rail. But what determines the firing of the fuel injectors on a common rail is the electronic control. So solenoids on top of the injectors are what actually determine the firing of that particular cylinder. So where you guys come in, and let's dive a little bit, since we're kind of on the fuel system side of it. Let's dive a little bit into the fuel system. So why is it so important for specifically like diesel engines? Why is it so important to have not necessarily your guys' stuff, but high quality fuel components in general?
So high high quality fuel components is super important because especially in a world today where you have stuff coming from all over the world, you don't know where it comes from. It's definitely important to have, your just the importance in just the metal that the parts are made out of, or all that all comes into play, and is going to be a big factor in the longevity of the parts. And not only that, but especially in the common rail stuff, the tolerances that we're dealing with on these things are within the millionth of an inch. And like in the machine shop world, we deal a lot of people deal in thousandths of an inch. In this world, we deal with in the tenths of thousandths, and then when you get into your common rail, you're dealing with millionths of an inch or microns, which is super small. And so just the tolerances and another big factor in fuel components is also fuel quality. And kind of growing up in the diesel family is what I'm going to call it. You know, some people grow up in a hunting family or whatever, but I grew up in a diesel family. And one thing that they always tell you is, and we all drive diesel trucks. My grandpa drove a diesel truck. All my uncles drive a diesel truck. I drive a diesel truck. And one thing that is super important that they always pound into your brains as you're growing up is, you know, make sure that you're not going to a crappy fuel station. Make sure that you're going to a quality fuel station, that the fuel hasn't been sitting there for months on end and they're filling up the fuel constantly. And so you always go where the big trucks are at. You always go where the semis are filling up. And then also with that is you never fill up your fuel when they're putting fuel into the tanks, because that mixes up the sediment all down in there. But that's just kind of something to tell you how critical that is. But just like the little particles in the fuel and the algae and stuff can totally wipe out your fuel system. And so not only the quality of the parts is important, but the quality of the fuel as well.
Well, and we had a switch fairly recently too with diesel engines across the board of the type of fuel we were actually running too. So what I learned with John Deere when I worked there is the ultra low sulfur diesel fuel that we have today did not used to be ultra low sulfur diesel fuel. So trucks like this were not made to run on ultra low sulfur diesel fuel. And what Deere told us is the sulfur in that fuel was actually a contributing factor to the lubrication of the fuel system. So when you started cutting out that sulfur, then like the newer engines and those components are more designed to run that, but these older trucks aren't. So you can start having like, you know, a faster wear in your fuel system. And that's kind of where the fuel treatments and stuff like that kind of come into play. I'm not super well versed on the fuel system treatments because at John Deere we only used like the BG fuel system flushes and additives and stuff. But the changes, like it doesn't sound like a big change, but that alone right there can like it's not like, oh, if you run the ultra low sulfur diesel fuel in a week you're going to trash a pump on these things. But it's just over time there's less lubrication in the fuel system because of that.
Oh yeah, 100%. The sulfur is a huge thing, especially in the fuel world. And we actually make an additive that adds a higher content of sulfur back into the fuel, because when they took that out of the fuel, that, like you said, was really bad for these fuel injection parts, because that's what they're not lubricated by oil or anything, especially in the common rail. I mean, that's what the lubricant is the fuel that's running through them, and sulfur is a very good lubricant.
Yep. And I'm pretty sure they did that change for after treatment, didn't they?
Yeah, I think it was for emission purposes or something like that.
It was something like the sulfur content was reacting poorly with the after treatment systems they were using, and so they had to, which don't even get me started on that, of the amount of backwards we've gone with that crap. But so you mentioned a few minutes ago and you touched on the types of metals in your fuel system components. So for those of you that have not seen the video that I did a while ago on the delivery tubes, and I'm sure this goes for more than just delivery tubes. So can you explain and kind of dive into that type of metal and the coatings and why that is critical for your parts?
Yeah, so most of the OE Bosch stuff is all the metals, but the fuel injection parts are around 60 Rockwell, which is pretty hard. And the tubes that you're talking about, what we found is that with these Chinese aftermarket tubes that people have been buying off of eBay, or I don't know where they're getting them, but they'll have a chrome plating on them to make them look good. And what happens is when that chrome goes and seeps onto your injector, it chips off and it'll start going through your whole fuel injection system. And we talked a little bit earlier about how tight those tolerances are. And as soon as those chips go through your fuel system, it just wipes the whole system out. And that's how you can have stuck nozzles. Your nozzles will get stuck open from those little flakes of chrome, and it can be detrimental to your fuel system for sure.
Well, so the Cummins common rail is 3rd gen builds around 20,000 psi of fuel pressure. So you guys work on a bunch of different a bunch of different engines. So what on average, like if you had to average a number between the Duramax, the Cummins, and the Power Stroke, what honestly, even the heavy duty side, what is the average fuel pressure that we are creating in those systems?
I'd say for the common rail, probably around 23 to 26,000 psi.
What about like Ford and Duramax? Do you have those numbers on hand? Well, do
I
they
don't.
even run common rail?
They do, yeah. Duramax,
Okay, I wasn't sure.
yeah. Some of them do. A lot of the Duramaxes still have they have the same CP3 pump, same rail system that the Cummins
Okay.
do. A lot of the newer stuff are kind of going to the DCR pumps and stuff like that, and the CP4 pumps, which are also a rail system, but we all know that those pumps are completely awful, and those are bad pumps. So
What about them makes them bad? Because I don't know anything about those. I know John Deere pumps, but I don't know anything past I don't know why I'm pointing at my 2nd gen. The CP3, I don't really know anything on Cummins really much past that.
So the CP4 pumps, the reason why they're bad is they have a cam in them, and then they have a roller bearing on a piston that rides, and that's the piston that pumps the fuel in there. And the actual piston doesn't have a slot in it like it should, and so what happens is that bearing in there can turn, and so
Oh.
it's not rolling anymore, and then that just causes it to wear a spot in it, and it just snowball effects and creates catastrophic failure in that pump. And
Well,
you can
yeah, because
actually,
imagine where all that shit's going.
right,
Right to
yeah,
your injectors. Yep.
yeah, and that's once the pump goes out, it wipes out the whole fuel system.
Yep. Well, and then I'm sure, if you have a metal contamination like that, I'm sure it's a lot like hydraulic systems where you may as well like replace not just the components, but all the lines and everything because you're never going to get all that shit cleaned out good enough to not have a potential issue in the future. So that's basically, your high pressure pump, all the fucking fuel lines, the fucking fuel rail, everything on the fuel rail, all your relief
Right?
valves, everything.
Yeah, that's
I mean,
why.
shit. I mean, that's if it doesn't get into the return fuel too. And then that's a whole nother,
Oh yeah,
yeah.
right. We sell a lot of conversion kits for those trucks that have the CP4s on them. It's
Hmm.
nonstop.
What year does the CP4 start? Just for
I
future reference.
want to say it's 2017, but
I really want a 4th gen.
2011. 2011,
Oh,
maybe. Yeah,
I was
yeah.
just curious.
Or for LMLs at least for the Duramaxes. I think for the
Okay.
Cummins it's 2017, but
Okay.
don't quote me on that. My truck, I have a 4th gen. It's a 2010. It still has the CP3 on it.
Okay. So I've wanted one. I want one. I don't believe in car payments, so I haven't gotten there yet. But so I just have a bunch of hunk of shits.
Yeah,
Um,
I feel you
but
there.
the O5 is the newest truck that I own. And the only reason I have that truck is because it was my dad's truck and he blew it up. And then it sat in his garage with the head off for like 3 years. And then he went to move to California to go logging up there. And he's like, this was my problem. Now it's yours. Here you go. Free truck.
Right.
So that's how I ended up with that truck. I traded him basically that truck for my running 1599 that I had. So that was fun. But that's the only
Right.
reason I even have that truck, or I'd still just be running this one and that one.
Uh-huh.
But so with the high pressure fuel, let's get into like the aftermarket side of it just a little bit, just a
Okay.
little bit, because I'm curious. I know the basic understanding of it, but I don't know like the in-depth of it. Um, if you have a high pressure pump, let's say, let's make it easy, the CP3, and you wanted to create more fuel. So when you guys make aftermarket parts, are you going for a higher flow or a higher pressure or both?
So the you get so the even when like in your higher horsepower ranges, you're still at the same pressure. It's just a matter if you're dropping pressure or not. So the goal with the CP3 pumps or the high output CP3 pumps is not to get higher pressure. It's to maintain that pressure throughout higher RPMs and higher and having it use more
Okay.
fuel, if that makes sense. So all of
Yeah,
the
that does.
all of the CP3 pumps are based off on in our books a liter per hour. So you have your I think like a stock pump runs at like 260 liters per hour at 5,500 RPM, and then we go all the way up to a XP600, which is 600 liters per hour at 5,500 RPM.
Okay. I was just curious. And then the injectors. So we all know that, especially on these older trucks, you don't actually have to replace the whole injector. You can just do the tip. So explain to the audience, I guess, what exactly makes an injector a higher. Some injectors go by, I've always bought injectors as like horsepower, like 75 horse injectors or whatever.
Right.
I know there's different terms for that, but explain to the audience what is happening within these injector parts to make them higher horsepower.
So when you're talking about a higher horsepower injector, it's usually I think ours is based off of a percentage increase of
Yeah.
fuel output, which the main thing that you are making bigger on the injectors is the nozzle holes. So you
Yeah.
go in there and EDM them out, and um, that's how you make them, the holes bigger, and then you just calculate exactly percentage over stock what that actually is. And that's kind of in the smaller stuff where you're just making the holes bigger, and then you get into your body mods and all your other big mods that we do for like the big Cobra injectors, for instance.
Yeah. So in theory though, if you were to drill out those little nozzle holes to a certain point, wouldn't you start having a balancing issue of you're dropping too much fuel pressure when that opens? Is that where having a higher output pump comes into play? Or am I completely wrong?
So you what I always tell people is it's always better to have bigger injectors than what you need, because I mean from a tuning standpoint, it's all based off of US, and US is how long your injector is going to be open for. And
Okay. Yeah.
so when you have a bigger injector, you can turn the US down, and which allows it because you don't want high US. Like on my old race truck, we would try to keep the US between 1,200 and 1,600, which was like unheard of. Like back in the day when we were building these race trucks, like we were running above 2,000 US, which was pretty much the injector was staying on the whole compression cycle of the piston, which is that's how you melt pistons and cause failures in the engine. And so that's why I always say bigger injectors is better, because it lets you get your US down so that the injector isn't on as long, because you want that injector
Okay.
on the least amount of time with the most fuel, if that
Yeah.
makes.
Yeah, that makes sense. Well, yeah, I can foresee how. So for those of you that, I mean, I would hope most of the people listening to this would understand this, but for those of you that don't understand, a diesel engine is not ignited by spark. It's ignited by the heat buildup from the compression of the compression stroke. And the fuel injector injecting the fuel into that compressed air is what ignites. So in theory, if you have that open too long and you're just, it's not like it's a gas engine where it's going into an air fuel mixture. and
Right.
kind of diluted. If you have that injector open for too long, that would make sense why that could burn up that piston. So
Right.
yeah, that would make sense. There was a bird task fucking piston on the engine that I ripped apart that was in my '05, and I don't even actually I know exactly how that happened. My dad was one of those people that bought a new set of injectors at some point in the life of the truck, and then kept the old ones that he knew was good, oh, I know
Right.
these ones are good. And
Uh-huh.
then I think the amount of times that he forgot that he swapped those out, and then I'm pretty sure that's what happened with the piston. At some
Right.
point, there was probably, because what people don't understand specifically with common rails is 20,000 psi is amazing for atomization of fuel, but it is fucking horrible if it's not atomizing right. And that's where you start like basically water jetting your fucking piston.
Right. And
So
just
yeah,
lasering a hole into it. Yeah.
yeah.
Uh, yeah.
I love seeing broke shit. I just prefer it to not be on my stuff. Um,
Right. Um,
typical mechanic, but yeah. Anyways,
a common thing is melting pistons down in these engines, and we see this a lot, like with bad, not only bad tuning, but also with bad injectors. People putting bad injectors or not having contamination in their fuel. That's what sticks the nozzle open, and like we said, it burns completely all the way up and down the stroke and melts holes in those pistons, and then they wonder why their engine melted down, and we're like, well, who tuned this thing? And yeah, it's a we can't control the point which aluminum melts. So
yeah,
I don't know what to tell you there. So
yeah. Well, at some point, it's if you're building aftermarket shit and you don't have somebody that understands all that shit trying to help you with it, it's kind of your fault. I mean, it's kind of your fault, but
right.
whatever. I mean, I guess. Or if you're like my dad that just would throw old injectors back in a hole and hope that it was good. And it's like, well, and that's what people don't understand too, is you can melt a piston with a stock injector.
Mm-hmm.
You don't have to have an oversized injector to fucking melt it. If you have a stock fucking injector and it's still like there's contamination or whatever, or a malfunction to where it is sticking open like that,
Mm-hmm.
yeah, it's just a fucking water jet into your fucking poor little piston. So
Right. Or you have a
yeah.
tuner that turns your US up to the moon. That's also, you could definitely melt a piston with stock injectors for sure.
Is that so? I have a question with the tuners. Is that something that like you would have to like, are you talking about the people that go and get specific tunes from people, or are you talking about just generic plug and play preset tuners?
I'm I'm talking about the people that you go and get them from, or whatever you're doing in the race
Okay, yeah. I had a
studio.
slight panic attack. So I'm like, I swear to fucking God, it's a generic ass. Because I know my limitations. I am not smart enough to know what a good tune like data looks like. So I just go and buy the generic Edge Juice with Attitude with the CTS3 monitor. And that is what I've ran on every truck I've owned. So, but
Right.
yeah, I don't think it's doing anything crazy like that. At least I hope it's not. But so for turbos, my ADD brain kind of like gets off on weird tangents, but the turbos, you guys also build turbos too.
Right.
And I don't know if I should really spend the time to get into how a turbo works. Basically, your engine puts out exhaust, which spins the exhaust wheel of the turbo, which then sucks air in from your filter and then spits it out the compressor and then into your engine, creating boost. So so you guys build turbos. How do you guys determine? So if let's say I'm coming to you and I'm like, hey, I got an O, let's just use this truck for an example, or this truck when I first built it. So I got an O2, I got 75 horse injectors, I have a stage 3 Colt cam, I've got a edge tuner, I've got 104-pound valve springs, my exhaust is port and polished. What turbo are you going to give me? Like, how do you determine based on the information I just gave you? I also have like air dog, so my low pressure side's good.
Right.
How would you determine that on what size turbo I would need?
So the first thing I'd ask is what you would want to do with the truck. That's the first question we
Yeah, that's
have.
true. That's a good
Like,
one. Yeah.
would they want to tow with it? Do they want to dyno it? Do they want to sled pull with it? you know, just depending on if you want it just to be a daily driver, exactly what power range do you want to be in, and those are the questions that we'd be asking. So I mean, for that truck, you probably want to daily drive it, I would assume.
Oh, yeah.
Tow with it, so you want something that spools up nice, and you want something that's not too big, so you're not lagging when you're towing, and but you probably want a little bit of a power upgrade with it, is what I'd assume, and it'd be probably be perfect for a 62 fat shaft or something along those lines.
So for those of you that don't, and you can add to this if you would like, because you probably know way more about this than I do. The general consensus with turbos is the exhaust wheel size versus the exhaust housing size, and then the overall size of all those components is kind of what determines how fast you spool. But it also can determine like how much you spool. So in a general consensus, if you have a smaller exhaust wheel, you're going to build boost faster, but you're going to top out faster on how much boost you can create. So you have a bigger wheel. That's awesome because then you can have a monster compressor wheel, and you might be able to build 70 pounds of boost, but it's going to take 8 business days to spool that motherfucker. And so
Right.
that's why when you're at a dyno or you're at a like a pull event or something, you sit there and you see them just freight train it for like 5 minutes because
Uh-huh.
they're spooling the turbo. Obviously, you don't want that when you're
Right.
trying to daily drive it because your EGTs are going to be through the fucking roof if you try to
Right.
do that. Yeah.
I'm a big fan of compounds. That's what I've always ran on my race truck, and it's just you can still have your big turbo, and you have your little turbo to spool up your big turbo, and so it's kind of it spools nice, and you have um your your flow that you want. So
I'm so happy to hear someone call it fucking compounds. I am so
yeah,
tired of hearing people call them twin turbos. It's not a
right,
fucking twin turbo. Like they are different sizes. What about that says twin to you? I
right.
don't know. But
There's
yeah.
there's twin turbos, and then there's compound turbos, and they work differently. So
Yeah. It always drove me nuts. Like, I got twin turbos. No, you don't. You have fucking compounds.
right,
And then they argue with you because it's the forums and everybody's right. And it's like, this is why I had to step away from Facebook.
right, yeah. Facebook can be a deadly place sometimes.
Yeah, the concept of compounds is like, you can have the fast spool of the little turbo and then have it feed a bigger turbo. So then the boost from the smaller turbo is actually what's spinning the bigger turbo, which
Right,
obviously is more flow than what your exhaust could be. So then that's where that comes into play. But then you got to make sure all your other components are made for that, or,
right.
things go boom.
Uh-huh. Exactly.
But so I've turbos are an interesting thing. So I have rebuilt a couple of them. And obviously it was in the private side because John Deere just ships you turbos. They don't let you rebuild them. But there was like a turbo I did for my friend and her Power Stroke, and that one you could just rebuild. My ex the ex that I was dating at the time, he had a third gen, and I have no idea if he was right or he was wrong, but he told me that when we rebuilt his turbo, he had to take it to a machine shop and have it balanced because some turbos, like the parts come balanced and some of them aren't. So can you explain that a little bit for me?
Yeah. So anytime you put a new part on, or something that we do to all of our turbochargers is we balance them before they leave the door, because I mean, even if you're reusing your exhaust wheel on it and you have to replace your compressor wheel or whatever the circumstance may be, that's going to throw it out of balance, and it's going to need to be rebalanced for sure.
So even the turbos that, if you read the forums, claims you don't have to rebuild them because the parts kits are already balanced. You should probably just have it balanced
It
regardless.
depends. If it comes with an exhaust wheel and a compressor wheel that is already balanced together, then that's probably okay. But
Okay.
if you ever have to reuse anything or something like that, it probably needs to. So those turbochargers are spinning in the hundreds of thousands of RPM, and you can imagine like what your tire feels like when it's out of balance, and that's only
Yeah.
spinning at however much RPM. Those wheels are spinning wicked fast, so when those are just a little bit out of balance, it can cause a lot of failure.
Yeah. Well, so the wicked wheel was a thing about 6 or 7 years ago when I was looking into things. What exactly is the difference? I don't know what your guys's version of the wicked wheel is, but what exactly is the difference between what people are calling wicked wheels and just a normal turbo wheel?
A wicked wheel is, I think it's just got different blades on it, and from my stand or from what I remember, and it kind of makes a little bit more noise and flows a little bit more air. It's pretty
So
much
is it just
the
the
same size
angles of
wheel.
it
It's just the same size
or
wheel with a different. I think it's just got a different count of blades on there, meaning like you could have a 8 blade compressor wheel, or you can have a 6 blade, and that's gonna
okay.
like a 6 blade is gonna flow more air, but the same concept we talked about earlier is the bigger the blades that you have on the wheel, the harder it is to turn it, but it flows more air.
Yeah, that makes sense. So for the audience, because I really try to pound this into people's heads, uh, EGTs, why the fuck would it be important? I already know the answer to this, but like, why the fuck would someone care about their EGTs, whether it's a stock or a non-stock application, down to things like, turbo, like cooling your turbo down before you shut it off and things like that. Like, can you explain to the audience, probably better than I ever could, why that's important?
Yeah, EGTs are a huge thing, especially in the machine shop world, because that's where you get the seats falling out of the Cummins heads on those high EGT numbers. When you're getting those seats red hot, that's where you get cracking in heads. You get warpage in the heads, and that's how you blow head gaskets. It's just EGTs are a bad thing, and especially I always that's another thing growing up in the diesel family. They always told you is make sure you cool your truck down before you turn it off, and
Yep.
that's to kind of get that's more of an oil temperature thing, especially
Yeah.
for the turbos. But getting that oil temperature down before you turn your truck off will definitely help the longevity of those turbos. And it's kind of funny because I was in a Garrett training thing, and one of the questions we asked the one of the Garrett technicians there is we're like, hey, and all these new cars that are all turbocharged and they all turn off at every stoplight, isn't that bad for the turbocharger? And he didn't want to say anything. So,
Yeah, that's definitely bad for the turbo. That's
yeah.
definitely, yeah. I had the same friend actually that I rebuilt the turbo on her 7.3 once. She went through like 4 turbos on that thing or something like that. And it was because I don't know if you're familiar with Laramie, Wyoming, but there's a big pass on I-80 going out of Laramie. And
Mm-hmm.
she would hook a fucking 4 goddamn horse stock trailer to that thing, put 4 horses in it, and tow 70 miles an hour up the fucking pass with an automatic, right? So it's not like she can stick it in fifth and rev it up and just pull. And she's like, I don't know why I don't know why it's melting turbos. And then I went on a trail ride with her and she's just wrong, like right past me.
Mm-hmm.
And like,
Right. EGTs are just a number out the window.
yeah,
That's
I've
crazy.
always learned that's why. And people always ask me why I buy manual trucks. Well, first of all, Dodge automatics are trash. Second of all, the main reason I like to buy manuals is because I don't care how good of a tow haul mode you have. Coming from places like Wyoming, I mean, I towed this maroon truck out here with this silver truck with a 24-foot gooseneck plus all my toolboxes. And
Mm-hmm.
I tell you what, it is nice to be able to stick it in fifth gear, rev it up to 2,500 RPM, and pull hills at 55 instead of, being stuck. Like, so what people like, I don't really know the science behind this. Maybe you can help me with this. Is it the higher, it's probably a flow thing, but if you have it at a higher RPM, even though you're going a little bit slower, if you keep your engine at a higher RPM, that will keep your EGTs way farther down than trying to pull it at 65 in sixth gear at a lower RPM. Can you kind of explain why that is?
Yeah, I mean, you're obviously probably have more boost pressure for one, and that's kind of cooling down. But also your coolant is spinning faster. Your coolant pump is spinning a lot faster and cooling the engine down a lot more too. One time I was pulling a trailer across the pass, and my fan went out in the truck and it started overheating. So how I got it home is I shifted the thing down, and that actually cooled the engine temperatures down enough for me to get home, just running at
Yeah.
RPM.
Yep. There's a lot of the general consensus with people, it is like, which I never really understood this until I had an EGT gauge with this maroon truck and I started pulling with it, is you would, in some aspects you would think, oh, if the engine's at a higher RPM, isn't it working harder? But it's actually not. If it's at a higher RPM, it possibly could be a little bit less of a load. And like you said, it's spinning everything and turning all the like the cycles of the coolant and shit faster. So that's also
Right.
super important for turbos because you can melt fucking turbos doing that. BJ, I hope you're listening to this. Nah, she's good. She figured it out. It's good. But so the last thing I want to touch in, I don't want to waste too much of your time today. So the last thing I want to kind of touch in and pick your brain on with some things is machine work.
Mhm.
And machine work, it is so fucking important. And I've told people over and over and over again, it is worth the extra $300 or $400 to have a reputable high-end machine shop do your work than the less 300, like $300 off Joe Smo in his fucking shop, right?
Right.
And a lot of that comes down to like what you were just telling me with the tolerances. And people don't understand. I didn't even know this until I went to a machine shop for this truck. Oh Lord, there comes the rain again. In this truck, that they can actually take what they did with this maroon truck is they took, and I'd never heard of this before, is they took each piston that they wanted and they labeled, I sent them all my pistons, all my rings, my block, everything. And they matched each piston to each fucking cylinder. So they didn't just do a generic hone of
Right.
20,000s. They matched it exactly to each thing. And I had no idea that was even a fucking thing because I
Right.
had rebuilt a couple of engines with my ex prior to that and nobody ever asked for that. They just asked, oh, well, what size do you want it bored out to?
Right.
So,
Yep. Most of all our engines that we build are all blueprinted for not only the piston size, but we're actually like from a take a factory Cummins block for instance. It
yeah.
might seem like the cylinders are all lined up perfectly from the factory, but they're not. And
Really?
one thing that blueprinting a block, there's actually a technical term for that, and that's we go in there and actually blueprint the block, and we put the cylinders where they're actually supposed to be aligned with the crankshaft, and that's a
Huh.
big thing that we do here. And
I never would have even thought of that. I would
yeah,
have just assumed that
right,
they were fine. Huh.
yeah. And then, and like you said earlier, like reputable machine shop is so important. Like I can't tell you how many cylinder heads that we get in here that the customer brought to a different machine shop and they just pretty much ruined the thing. And it's just they have to pay for it twice at the end of the day.
Yep.
And I mean, if you want it done right the first time, just take it, and you don't want to have to pay for it twice. Take it to a reputable machine shop, and that's the best way to do it. And that's going to be the most cost effective way to do it as well.
Well, yeah, 'cause it doesn't matter if it's even $500 cheaper to have it done somewhere else. You have to do it twice. It's going to be
Right.
more expensive. That's if you can even keep that component now. Like, I know that cylinder bores have a maximum. And so what I ran into with my ex at the times, like what we ran into with his 12 valve is he had it bored over like 40 or 50 thousandths, like insane.
Mm-hmm.
And what we did not realize at the time until afterwards is yes, your cylinder walls are not technically too thin or whatever. May not crack, but what was having an issue is cylinder temperatures were a problem because they
Mm-hmm.
were like too, I don't know. That's just what he told me. I guess, or I've been told, maybe you can elaborate on that a little bit more.
The cylinder temperatures themselves were too warm, huh? Is
Well,
what you're
that's what
saying?
we were told, is that the cylinder walls were so thin because of how much it was bored out that it was causing too much heat transfer. Maybe that's bullshit. If that's bullshit, tell me, because I'd be more than curious to know.
No, you're exactly right. If those the so the thinner those walls are, the easier the heat is going to be able to transfer onto those walls. So that's definitely a thing. If it's honed or bored out way too much, um, that could definitely make it hotter for sure.
So what would be your max that you would bore? I'm not going to try and ask you every single engine because they're all different, but on basically a 5.9, pretty much, the 24 valve common rail, all of it, the blocks are almost pretty much the same, almost.
Right.
What would be the max that you would suggest people bore their stuff out to before they start having to go back to sleeving it?
On the early 5.9 stuff, the 12 valves and the 5.9s, they have a lot thicker cylinders. So the maximum we'd go on those is probably 40 thousandths over.
Okay.
And then on the 6.7s, the maximum we'd go is probably 20 because they're a little bit thinner.
So is the 6.7, is the block itself different, or is that one of those things that the manufacturers did where they basically made a 5.9 block and bored it out?
It is a little bit different. It's pretty much a Siamese is what they have Siamese cylinders on them, meaning they have coolant that flows between the cylinders. On the
Yeah.
5.9, the coolant doesn't go between the cylinders, and then you have your
Okay.
speed ports in it, and so it's pretty much the same thing. They're really similar, but not exactly.
I wish they would make linered smaller engines. I know that like the O-rings can cause leaking and there's like I guess more components to fail, but for the rebuild ability of the overall life of that engine, wet linered engines
Mm-hmm.
is, I think that there's a reason heavy duty. And for the audience that doesn't know the difference, any like 5.9 or 6.7, if it's been machined with a sleeve, it'll just have a dry sleeve, but it's what's called a parent bore, which means the the bore of that cylinder is bored directly into the block itself, which is also what most gasoline cars are. A liner, specifically a wet linered engine, is literally that whole cylinder sleeve is a complete part that you can take out of the engine. And coolant flows all the way around it. It cools better that way. Yes, coolant can leak out of those O-rings. I've seen that before on Deers a couple of times, but those in a theory, when you just do a rebuild, you can literally, some of them come with the piston separated, but some of them are literally what they call jugs kits, which is the fucking liner and the piston and the rod assembled and everything in there. And you literally just plop the liner in and well, you got to check the clearances and shit, but basically just plop the liner in and you're fucking good to go. So
Right. Yeah, it makes it way easier for sure.
I think it also like, that's a smart thing if you're thinking about rebuilding it. And that's the best way to do it because then you don't have to run into like this maroon truck. I have a board over 20,000. It's fucked, dude. It is fucked. I have no idea what happened. So I ran it for 80,000 miles. Mind you, I was broke when I built that engine. So I bought like a mall rebuild kit off of eBay. So
Mm-hmm.
I have no idea if it was actually mall, but I bought it off of eBay. And things like that. I did use the best machine shop I could find because I knew that was important. But about 2 weeks before I was supposed to move all the way across the country a few years ago, it
Mm-hmm.
started having this knock, and it almost sounded like a fuel knock. And so
Right.
I dove into the fucking fuel shit. Wasn't anything. I pulled my valve cover off. And I'm like, oh fuck. Looks like a fucking stripper took a bath in my oil.
Uh-huh.
What the fuck? So I pull my oil pan off, and number six, of course, is you can sit there and you can move the piston in the cylinder. And
Oh
I
wow.
don't know if it's the wrist pin itself or if it's the bushings in the rods or in the rod or what, but that entire cylinder wall is completely scorned to fuck. It still starts and runs. It just
Hmm.
sounds like fucking death, and I haven't gotten to the point of fixing it yet. But I don't even know what that could have been because the machine shop is super reputable. There's not much you can fuck up with that either. Like
Right.
there's not much with the wrist pin itself that you can really fuck up. So I mean I haven't taken the head off, but yeah.
Yeah. So one thing we do is we put new wrist pins in every build that we do. It's kind of something off the scale. It's just something that we do to make sure that our quality is good. But what will happen is once those wrist pins wear out eventually, and then you put a new pin in it, new piston on it, it'll cause what's called a hammering effect. And if
Mm.
that bushing originally wasn't what the right oil clearance is supposed to be, and it was way big, that could cause a hammering effect and could wipe out that bushing in seconds.
Wouldn't it do it for all of them though?
Depending on how good each bushing looked, I guess that you just have
Which the bushings were replaced, but I did not do those. The machine shop did those for me.
to.
I
Right.
actually don't remember if I put new wrist pins in it or not. I don't remember.
Right. One thing
Um,
that we do differently than a lot of other people's shops is we wedge the bushing before we bore it out to the size. And what that does is once you can't just press the bushing in and then cut it to your size because it causes the hammering effect, like I said. But we go and swedge it out. So after we press that bushing in, it goes and swedges it all the way out as far as it can go to the edge, and then we'll bore it to the right size.
that would make sense. Yeah.
And that's what, if you don't do that, it causes the hammering effect, just like I said, and it'll swedge itself out, and then you'll have way too much oil clearance. And
Yep. That would make sense. And like I said, I'm not super confident in, I want to be confident in the machine work, but I'm not super confident in the quality of those bushings either, just
right,
because of where I bought the kit. So, which it is interesting that it's only one cylinder that's doing it.
yeah,
It's only number 6, but it is, I mean, I only drove it for maybe 100 or 200 miles like that because I thought it was a fuel monoc,
mm-hmm.
but it is the fuck scored. It's horrible. So I don't even know if I can get that bored out without going too far over. I may have to sleeve that engine, but
Right,
it sucks that that was only 80,000 miles and it did that. And when I thought the reason I have an issue with the parts that I'm worried about, which honestly, it could be my fault, but I don't really know how I would have fucked that up besides maybe if I didn't get the snap ring in right, but I am super anal about that shit. And there's like, not saying it's not possible, but I'm like almost certain there's no
mm-hmm.
way I fucked that up because I am super anal about shit like that. So,
Right.
and even then,
Also,
sorry, go
uh,
ahead.
number 6 is also the one that gets the hottest, the
Yeah.
hottest cylinder. And so if the piston to wall clearances weren't exactly right, that could have also caused some cylinder failures there too. But
Yeah, well, and it could have been the piston too if the piston's too cheap. It could have
right.
worn the piston. And so I have a lot of like, when I first did that engine, every single motherfucking gasket on that thing leaked. I worked for John Deere for fucking 7 years. I've had gaskets leak here and there that I put in, but not every fucking one of them. And sure as
Right.
shit, go to Dodge and buy an OEM gasket and it's fine. So
Mhm.
like every single gasket I had on there was fucking trash. So it started to make me wonder like what is the quality of the fucking bushings that they gave me and the rings
Right.
that they gave me and the pistons, and now I'm fucking worried. That thing ran fucking great, though. I loved the way that truck ran, but now it's fucking dead.
Yeah.
But when I get to it, I'm probably gonna send you guys at least for the block and shit for the machine. I obviously can't do the fucking machine work. Probably send you that block once I get to it. I've been saving that for a kid, whether it's a step kid or my kid or a fucking my best friend's kids. One kid wants to help me build that, they can have it for free for their
Right.
16th build. That's what I'm saving that truck for. But
Well, that'll be a good purpose for it.
like, that's the only reason well, I keep trucks because I have an attachment issue. But that's what I'm telling myself as to why I'm keeping it. I think it would be fun to have an engine little like, oh, you know, you got to fix it to work on it. So then maybe you respect it enough to not completely fuck it up. I mean,
Right.
obviously they're kids. They're going to go out and do burnouts and roll coal because it's fucking fun. But maybe they'll respect it just a little bit more. And that is going to make you the coolest fucking kid in the parking lot. It's got 35-inch tires. It's going to be awesome for whoever kid. I wish I had that truck in high school. I had a 92 D150 V6 two-wheel drive was my first truck because I had to have a Dodge and that was the only one I could afford.
Hmm.
So yeah,
Yeah.
but
My first truck I had as a daily driver for as long as I could, and then it turned into a race truck before I could even know it. And it was first like, oh, well, I just want a good streetable, high horsepower truck, and then it turned into full race truck. It just never stops from there. It just
it
keeps
doesn't
going up.
stop. It's an
And then
addiction.
yeah, and I ended up selling that truck to my little brother, and I'm building another one. That's all full tube chassis and fiberglass body that we're gonna hopefully take out to UCC next year. So
That'd
it'll
be
be
cool. Yeah,
fun.
they said that had like 3 trucks planned to actually compete and none of them made it. That's
Right.
what the guys at UCC said. So, which I got
Hmm.
to see the fan dyno truck that was there,
Right.
which
That
is
was that was my old truck. That was my little brother.
okay.
Yep.
That's pretty cool truck. It's pretty cool. I felt weird like talking about it because it's not my truck and I have a weird thing with like not
Yeah.
taking pictures and videos with other people's truck. It's just like
Yeah. That's kind of
weird to
yeah.
me. Uh, but it's a cool truck, and it's like I could only fucking dream of making 20. I think it was like what 2180 or something like that on the
Yeah.
dyno that it made. I can only dream.
Yeah.
I would have been happy if that truck made like 400 horsepower.
Right. Yeah. The max
I would
that
have loved to
made
seen
is
the torque rating on that thing too. If the fucking horsepower rating is 2180, what the fuck is the torque rating? That is what I want to fucking know.
think it was around 26 or 27.
Oh, he told me they didn't fucking test that.
Oh, they test it. And then
Motherfucker.
the most
He just
that
wasn't
truck
paying
made is
attention.
that truck's made 2476 before, and it was close to 3,000 torque on it.
That's awesome. Because for the audience that doesn't understand, like horsepower ratings are cool, but the torque with the diesels is actually what's the most important rating. Like the horsepower is cool and that obviously is important, but diesels are the way it's an inline six and the way the fuel burns is a really great mixture for torque.
Right.
So, which is why equipment uses them and semis use them,
Hmm.
which is
Right.
also why inline six gasoline Jeep engines make me fucking laugh when they say they
Yeah.
built horsepower. 'Cause I'm like, first of all, you're an inline six. Second of all, you're a gas. So like that just like doesn't really match. But okay.
Right.
Your Jeep's cool, bro. Your 90s Jeep Cherokee.
Right.
Congratulations.
Yeah.
I have a problem with Jeep people. I'm not trying to hate on anybody with Jeeps. I just have been traumatized by my ex's family that was obsessed with Jeeps, and it was like literally it's trauma. Okay, it's trauma. It's like I'm millennial. I can say the stupid shit's trauma. So
If anyone wants a diesel inline six car SUV, those have you seen those BMW 335Ds?
I have it. I've seen the 4BT Cummins, but I haven't seen which
Those,
obviously is a 4-cylinder. But
those are just like a little common rail Cummins is all it is. It's an
that's
inline
awesome.
common rail system on it. They're
That's
pretty cool.
awesome. That would be perfect for like a little rock crawler thing.
Yeah.
That'd be perfect for like a little Jeep because those Jeeps have zero power. I do not care how much you love your Jeep. When you bolt 35-inch tires on it that are 15 inches wide and they're fucking bias ply, mud super swampers, you don't have power.
Hmm.
Sorry, you just don't. I mean, unless they like go through and like basically say because they're not even an actual frame, most of them. They're like tube frame, which is fucking stupid. Not to get into Jeeps, this isn't about Jeeps, but that would be perfect, a perfect little engine for like the rock crawler Jeeps.
Hmm.
That would
We
be
built a
perfect.
lot of those 4BT Cummins for the rock crawler stuff. They love
Yeah,
the.
well, it got the low end torque, which is exactly what you need for rock crawling.
Hmm.
So, yep. Well, is there anything else you would like to add or discuss?
I not much. Thank you for having me, and we want to see you at Diesels in the Mountains. So,
Oh, bro, I wish I could make it to that. That's so fucking far away right now. Is
yeah.
Bandamere even still there?
Nope.
Yeah, I thought it got taken down. I'm so glad that I went to all the fucking NHRA races while I was there because that
Oh,
made me
I
sad.
meant Diesels in the Mountains, not on the mountain. There's
Oh,
that's
okay.
Diesels in the Mountains is the event we do down here in Richfield, Utah. About
Oh,
600 feet.
okay. That'd be cool. I mean, if I could make it, dude, I don't trust a single motherfucking truck I own to drive that far. So I would love to, but I do not trust a single motherfucking thing I own to drive that fucking far.
Right.
But yeah, so if anybody is interested in more industrial injection stuff, they have a whole blog and they have a pretty big social media presence. I'm sure you guys have seen me tag them in like fucking everything. By the way, apologize for the low quality videos that I did initially. I finally got my shit together with like a small camera and I got my shit together with the filming. So I apologize for my filming being a little bit like mediocre before. But I got it now. So for those of you that don't know, I did a video and I have a 62 fast shaft turbo from them on Freya, which is my 3rd gen. I have a full set of injectors from them, which are stock injectors and delivery tubes, and a valve cover gasket that I bought from them. I also have a fuel or not an intake plate, which I actually bought myself. And then what else do I have? Oh, the pulleys, all the pulleys and idlers from you guys. So they have a lot of stuff, and it's like they actually helped me out with their fuel injectors because I wasn't stupid. I bought a brand new set of injectors for that truck and it was just nothing but issues. Not only did you guys find out through testing them that a bunch of my fucking injectors didn't actually meet specification, but the fuel delivery tubes that they gave me were chrome plated, as we've stated before as to why that's a problem. And the
Right.
fucking fuel lines, I wish I could find them. Hold on, let me see if I can find them. Where's the stock one? I have so much fucking crap. I have like 3 common rail engines worth of fucking parts on my shelf over there.
Yeah.
I don't know what to fucking do with it all. I can't throw it away. I'm a fucking pack rat. Well, I don't know what happened. I must have thrown away the the other fuel lines. So you see how like the stock ones have the indentation or the cone to go into the delivery tube nut?
Right.
So the lines that I got from that fucking kit were just cut flat.
Yeah.
So obviously, when you go to fucking tighten it, it's like it starts contacting that nut and it doesn't seal all the way, dude. I fought fucking fuel leaks on that thing. So annoying. I ended up buying all new
Right.
fuel lines from Mopar
Yeah.
because I was just over it. But yeah, I got those are like I think that's the complete. Oh yeah, I have a fuel filter delete block from you guys too, which another part that I bought from another company, and it was like some plastic piece of shit or something, and the threads were like fucked up. So you guys sent me the nice like billet one, which is not. I just like it. I think it cleans the engine up a lot. So those are the parts list that I have from industrial injection. Again, I promise this is not an ad, but um, well, thank you for your time and thank you for coming on here. I really, really want to like use this podcast to dig into like the specifics of things. I don't want to be like, oh, here's a generic thing of how a fuel system works. I want to really dive into like and have experts in here dig into like the real technical sides of things for people and for me too,
Right.
because I always want to learn. I
Oh yeah.
I want to learn new shit too. Even though I was a technician for professionally for almost 8 years, you still have a lot of shit to learn. I still have a lot of shit to
Oh
learn.
yeah.
So
You definitely
um,
impressed me. You definitely know a lot. So
you can
definitely
thank
just
Deere
cool
for
to have.
that. I went through so many capstone training classes for them, but and diagnosing a bunch of fucked up shit. That's how you learn is when you spend 5 days trying to diaggnose something fucked up.
Right.
But Well, thank you for your
Thank
time,
you.
and I appreciate you coming on. And if there's anything else you want to like do another episode on and dive into more, I'm here for it. So just let me know.
Okay, will do.
All right, thanks.
Yeah.
Bye.